Welcome to the screencast entitled A Quick Trip Through Openness, Freedom and Transparency. My name is Konrad Förstner and I'm doing my PhD in Per Borg's group at the EMBL in Heidelberg, Germany. I gave this talk at a retreat to other PhD students, but I thought I should make this available to a broader audience. It is mainly, but not exclusively, aimed to scholarly viewers. I should start with a disclaimer. The talk covers many linked topics, but only in an introductionary way. I had to simplify a lot, and there are some idealizations and polarizations to crystallize the message. And especially in the beginning, it is a little bit tacky. I hope you agree and know from your personal experience that openness, freedom and transparency are important values, not only in the scientific community, but in society in general. In the following, I want to show you how the increased implications of these attitudes improve science and society. Open source is my first example where these concepts can be found, and I would say it is also the origin of the movement that tries to apply them to other fields. So, a short definition of open source software. It is computer software that is published under a license that gives the freedom to use, modify and redistribute it. Not sure if everybody understands this now, but the next slide will hopefully help. We have to get some background and learn how software is produced. If somebody creates a program, he or she is writing this in a programming language, for example C, which is a way that human can understand. The result is called source code. To produce a program that can be understood and executed by a computer, this source code must be translated into binary code. This binary code cannot be read by a human anymore. Usually, if you buy software, you receive these executables and don't have access to the source code. This is closed source software. But there are projects and companies that offer not only the binary code, but give you also access to the source code. They publish this source code on an open source license. There are many different names for this: free, libre, open source software. The licenses that are used make the code free. Free as in freedom, not as in free beer. So we get certain freedoms. There are many different open source licenses. Two of the more important ones are the GNU General Public License and the BSD license. They give the same general freedoms but have different attitudes and some details. But I will not go further into those differences. So, what are the freedoms we are offered by open source software? At first, it's the freedom to use the software in binary form. Next is to create copies of it. But now the important part. We get the freedom to modify the code, and we are allowed to redistribute the code we received and also our derived versions of it. Okay, how do we profit from these given freedoms? Open source software offers transparency, which has many implications. Let's have a look at closed software programs to get the point. They are basically black boxes. I don't know what such a program is doing on my machine. It could log my keystrokes, scan my disk and send the report to somebody else. I cannot check this. But as I have access to the source code of open source software, I could see exactly what it is doing under which conditions. Due to its transparency, open source software has potentially a higher quality as more people can look for errors. Imagine it as a huge peer review process if you find enough people who volunteer to check the code. Open source software also makes you independent of vendors. If you buy a closed source software program and the vendor becomes bankrupt, you don't get the security fixes and things like that. With open source software, you or others can still improve the program even if the vendor or developer stops the development of the program. You can also adapt open source software to your needs, and you can make use of parts of the program to create your own applications. And, well, you get it for free or low price, so it's affordable for nearly everybody. Actually, I am pretty sure that open source software is nothing new to you and you have already encountered it at some point. I guess you've heard about or used Firefox, the web browser. How about OpenOffice? Maybe even GNU Linux, often just called Linux. Or have you heard of GIMP, the open source equivalent of Photoshop? Well, there are other examples that are less obvious, but you have used them for sure. Around 50% of the websites are hosted on the open source web server Apache. So when you're browsing through the web, you get the pages from it. If your browser asks for the IP address of a web server belonging to an URL, a web address, Bind will give you the answer to this question. It is the de facto standard for DNS servers, and it is open source. And last but not least, Google could not exist as they do right now if they were not able to use Linux and adapt it to their needs. There is an endless number of examples like this, but I have to go on with the talk now. My next topic are open formats or open standards. They are publicly available specifications for storing digital data that are free of legal restrictions and free of charge. Let me explain this to you by using an analogy, the ISO container. The dimension of these containers are public known values, and everybody can build ships, trains, trucks, or anything else to make use of the containers. It is an open standard and revolutionized the global transport of goods. Open standards can be found in IT too. Here I have compiled some examples of closed standard, so-called proprietary formats, and their open equivalents. I guess Word and Excel files are known by everybody. They are closed formats developed by Microsoft, and the same is the case for the new format Office OpenXML, although the name implies the opposite. An open format that fulfills the same function is the Open Document Format, ODF, which is used by Office suites like OpenOffice or KOffice. Then I listed some examples for instant messaging. ICQ, MSN, AIM are proprietary format. Jabber is an open source and popular instant messaging protocol. Google was again very clever and is using it for Google Talk. Skype is used by many for voice over IP, but among some other hooks, it has a proprietary format. There are many SIP-based solutions for this that are open. In my opinion, the most important open format that has luckily no proprietary competitor is HTML, the language used to write websites, and it was crucial for the development of the World Wide Web that it is based on an open standard. Open formats have the advantage that you're not bound to a certain vendor or application, but can select the best one for your needs. You can even write your own applications if you want to. And if you need to access data in 20 years that you save today, you might run into trouble if you use the proprietary format and the vendor is not on the market anymore. With open formats, you will not have that problem. So, here we come to the next topic, Creative Commons. Let's assume you're a creator of a text or a piece of music and want to share this with others. Per default, you have copyright on this, so others are very limited in using your creation. You could publish it under public domain, so everybody can do anything with it, and you don't have any control anymore. If you want to have a license in the middle of those extremes, Creative Commons is a solution for you. But first, let's ask why this is necessary at all. Today's culture gains a lot from the fact that digital media can be exchanged and used for new creations. Copyright is hampering this culture development. Creative Commons helps you to define freedoms in an easy way. You can use CC licenses for all kinds of creations, for example for text, images, audio or video files. So how does it work? You select a license simply by choosing the conditions you want to apply when sharing your creation. If you want others to mention you after they make use of your creation for their work, you choose the attribution condition. If you want to share your creation but don't want people to modify it, you choose the no derivative works option. You can also allow non-commercial use only. With the share alike condition, you give other people the right to use your creation as long as the resulting product is shared with the same license. The combination of these conditions lead to different licenses. You see, it's not rocket science and you don't have to study law to understand this. Now we reach the open access topic and the more scientific related part of the talk. Open access is a publishing concept with immediate, free and unrestricted online access to scholarly publications. Okay, let me show you what I meant by this by describing the currently mainly occurring scenario, the closed access publishing. Funded by the public, scientists do their research. When they finish a project, they write a manuscript and ask the journal to publish it. If the journal accepts the manuscript for publication, nearly all rights are given to the publisher. Other scientists want to build on the new knowledge and buy the publication from the publisher, if they can afford it. This means the public pays for the research but loses all the rights to the publisher and the knowledge access is limited. Open access provides an alternative to this and makes the created knowledge available for everybody. There are two different ways of implementing open access. The first one is using an open access publisher who's paid by the author or has other business models. Importantly, the author keeps the rights of the publications, which is now freely available. Often a Creative Commons license is used for this purpose. The second way is self-archiving. Some publishers give authors the right to use the preprint raw manuscript of a publication for their purposes. These can be submitted to so-called preprint servers like Nature Proceedings, where they are accessible for free. The result of both ways is that the created knowledge is immediately available for everybody free of charge. As there's no financial hurdle for the reader anymore and the knowledge is not locked away, the publication has potentially a higher scientific impact. Another often forgotten advantage is the improvement for computation analysis that the availability of the full text brings. It is hard to keep pace with the growing amount of literature. Text mining can be a helpful tool and gives much better results if the input is full text, not only short abstracts. So with this I'm coming now to my last topic, named open science, open knowledge. These are very fuzzy expressions and not clearly defined. I want to start with some thoughts that I think a lot of people don't consider. Firstly, that the mission of scientists who are funded by the public is to create knowledge for the public. Also, that restricted or delayed access to scientific results hamper science in general and can even cost lives if you look at medical research. In my opinion, people also should be aware of the fact that even negative results are results and are worth being published. And last but not least, I would like people to question more if the paper, as we know it, is still the optimal form of scientific communication in the age of the internet. With this in mind, I will present you some examples that I would place in the category of open science, open knowledge, and that show alternatives to the current modus operandi in science. The first example is PLOS ONE, an online-only open access journal. They perform a pre-publication peer review process, but don't filter for scientific relevance, as every result is valid to be published. Once a publication is online, it can be rated and discussed by users. Science Commons, the name and the logo makes it obvious that the roots are lying in Creative Commons, try to remove legal and technical barriers that occur in scientific collaboration and innovation. One endeavor, for example, is the Biological Material Transfer Project that is supposed to make the transfer of biological material like proteins or cell lines easier. Wikipedia and associated projects like Wikibooks or Wikiversity are, in my opinion, excellent tools for communicating science to a broad and not necessarily scientific audience. Due to the underlying wiki technology, they are very easy to use. Also, minor contributions make the project grow, so the minimal unit of effort to invest is very small. Another wiki-based project is OpenWetWare, which is a communication platform for scientists where knowledge for specialists like protocols for experiments can be exchanged. If you're a scientist, you have a lab notebook, which has the purpose to document your daily work and results. In Open Notebook Science, you do the same but give everybody access to your results by using blogs or wikis as a notebook. This means your results are instantly accessible by everybody and you can get direct feedback from your community. It also means that failed experiments are reported. My last example is called WikiScience. The idea is that an article is not a static document anymore, but a wiki page that is constantly improved by many scientists working in that field. The amount of authors that could contribute with their micro-publications could be much higher than in a classical paper. I showed you some examples and admit some of them sound slightly crazy in the beginning. With the current scientific community, we have problems implementing them. For example, you might be scooped if you make your results available online before a real publication, or you might have problems publishing them later as the journal sees this already as a form of publication. There are also no credit systems for scientific contributions like Wikipedia entries, blog postings, or contributions to online discussions, etc. But the good news is that these are mainly cultural problems, not technical ones anymore. And you can find more and more people who are playing around with the new ideas to improve the way we do science by using more open and transparent ways. We are at the end of the talk now, and I just want to give you my take-home message. I hope I could convince you and give you enough examples that show that more openness, freedom and transparency can improve many fields, and that science is one of them. If you want, you can help by learning more about all this, testing, discussing, promoting and applying it. I want to thank all the countless people who make this talk possible by making their opinion and ideas online available. Many thanks are going to Bernd Ahlers, who introduced me to the topic of open source, and many thanks to Anne-Marie Glynn for feedback. And finally, thank you for your attention.